हेलो एवरीवन, वेरी गुड इवनिंग। कैसे हो सभी लोग? हाउ इज एवरीवन? ऑल गुड? एम आई ऑडिबल? एम आई विजिबल? चलो, लेट्स डू फर्स्ट टेक्निकल चेक. If everything is fine to go with or not, let me know. Okay, thank you, thank you, thank you. Okay, great. Then we are good to go, right? Let's start. Lakshmi, hi. I hope you are good. Chalo. So, largely in the today's class, we are going to discuss dipole, then electric field due to dipole, then electric potential due to dipole. So, our discussion will be today revolving around dipole itself. उससे पहले कल के क्लास में हमने क्या पढ़ा था उसको रिवाइज कर लेते हैं. So, we started with electrostatic potential, and whatever definition I gave you in the yesterday's class, that was correct basically. Everything that I did was correct. Actually, I got confused a bit at one particular point, and I will explain you what was the confusion. So, if there is a positive charge Q, and I said if at distance R, you are going to calculate potential because of this charge, then this is KQ by R. How we calculated it? For this, we took a test charge. Yani ki here there is plus Q charge, which is fixed. And then we took a test charge of value I mean, it's a charge having very smaller value, and it is initially at infinity, and now we are trying to take it closer to the charge plus Q. We are trying to take it closer in such a way that this small Q charge, that is test charge, is not accelerating. And for it to not accelerate, what is important? Important is there is already electrostatic force acting between plus Q and small q if separation between them is finite, right? And that electrostatic force will repel this test charge, and magnitude will be this much at any separation R, right? So if we have to make it move with constant velocity, or simply we have to, we have to move it from infinity. At infinity, it was at rest, and we have to take it to point P. Then we have to shift it to P in such a way that at P also it has no velocity. I mean, no work is happening on this charge Q. And this is only possible if net force acting on the charge is zero. And since electrostatic force is acting in this direction, external force we applied, this is electrostatic force, external force we applied in this direction. So basically, whatever amount of work we are doing in bringing a test charge from infinity to point P is getting stored in the form of potential energy, and that potential energy per unit charge was taken as what? That was taken to be equal to इलेक्ट्रोस्टैटिक पोटेंशियल. ठीक है, तो मैंने कैलकुलेशन कुछ ऐसा किया था. वर्क डन बाय एक्सटर्नल फोर्स, स्मॉल वर्क डन क्या होगा? F dot dr. So if you check here, external force is in this direction, displacement is also in this direction, so F dr cos 0. And if you see here, one mistake happened, that was this with this dr thing. See here, initially charge is at infinity. Initially charge is at what? Infinity. यानी कि initial separation is large, and finally at any other time separation is less. So if you will calculate displacement, final displacement minus initial. So let's say initial was R1, final is R2. So if you see here R2 minus R1, this one I'm calling as dr for a small distance. This will be dr, otherwise it's delta R. And if you check clearly, R2 minus, carefully, R2 minus R1 equal to delta R will be inherently negative. This is going to be negative. Why? Because R2 is less than R1. And since this is inherently negative, यहाँ पे वर्क डन को पॉजिटिव करने के लिए, क्योंकि हम मैग्नीट्यूड लिख रहे हैं, ठीक है, वी आर राइटिंग द मैग्नीट्यूड ऑफ वर्क डन, सो इट हैज टू बी, आई मीन, if cos 0 is 1, force का value we will write, dr का value we will write. We won't write it with negative sign, but dr is inherently negative, and that is why to make it positive, we will give here negative sign. ठीक है, अगर अब आप इसको सॉल्व करोगे तो कल हमें जो भी आया था सेम थिंग वी विल गेट विथ ऑपोजिट साइन. सो टोटल वर्क डन विल बी इक्वल टू, डी डब्ल्यू को क्या लिखोगे आप, फोर्स को ब्रेक कर दो, के क्यू बाई आर स्क्वेयर डी आर. ठीक है, विथ नेगेटिव साइन, टोटल वर्क डन डब्ल्यू माइनस के क्यू, और इसका इंटीग्रेशन विल बी व्हाट, माइनस वन बाई आर. सो R will vary from infinity to any value R naught. So you will get here plus KQ by R naught. And this is work done by external force. ठीक है, KQ होगा यहाँ पे, सॉरी, force क्या होगा, KQ by R square. So this is the work done by external force, and work done per unit test charge by external force is equal to potential at that point. So that will be equal to KQ by R naught. So this was the answer. हमारा मिस्टेक ये हो रहा था, वी वर गेटिंग इट नेगेटिव, बट पॉजिटिव चार्ज के लिए पोटेंशियल पॉजिटिव होना चाहिए. व्हाई वी वर गेटिंग ऑपोजिट, क्योंकि हमने डीआर के साइन को इंक्लूड नहीं किया था. डीआर का मैग्नीट्यूड लिख रहे हैं ना हम, जब एफ डॉट डीआर कर रहे हैं, वी आर राइटिंग मैग्नीट्यूड ऑफ फोर्स, मैग्नीट्यूड ऑफ डीआर, देन cos 0. Magnitude of dr is inherently negative, so to make it positive we need to give additional negative sign. That is why this was required. ठीक है, so everything was correct. और हमने क्या पढ़ा था कल की क्लास में, वी स्टडीड पोटेंशियल एनर्जी ऑफ सिस्टम ऑफ चार्जेस. सो फॉर टू सिस्टम ऑफ चार्जेस के क्यू क्यू बाई आर, if it is separated by distance r, if there are more number of charges in a system, then how we calculate potential energy of the system. इसके लिए we first calculate how many pairs we are going to do. So pairing thing we identify by the formula NC2. So for three charges there will be three pairs basically, and if it is R1, if it is R2, if it is R3, we will write potential energy like k q1 q2 by r1 plus k q2 q3 by r1 plus k q1 q3 by, sorry, this is r1, this is r2, q2 q3, and this is r3. So this is this, है ना. कल के क्लास में हमने ये चीजें पढ़ा है. उसके बाद हमने एक और इम्पोर्टेंट चीज पढ़ी थी, इफ देयर इज इलेक्ट्रिक फील्ड इन अ रीजन, and then if we are calculating potential energy of system of charges, then I told you, let's say there are 2 points, point A and B, and here there is charge q1, charge q2, and external electric field is E, let's say, then potential energy of system of charges now will be equal to what, q1 into potential at point A because of electric field plus q2 into potential at point B because of electric field, then potential energy because of two charges q1 q2 at a separation of, let's say, r. So this whole will be the thing. ये हमने पढ़ा था. उसके बाद हमने डाइपोल पढ़ा था. व्हाट इज डाइपोल? डाइपोल इज बेसिकली सिस्टम ऑफ नेगेटिव एंड पॉजिटिव चार्ज सेपरेटेड बाय अ वेरी स्मॉल सेपरेशन, दैट इज कॉल्ड डाइपोल. We indicate dipole by a letter P. Dipole is a vector quantity, so its direction is from negative to positive charge. And what is the magnitude? Magnitude is value of any charge into distance between these two. This is your electric dipole. ठीक है. After that, we calculated electric field at equatorial point. I told you there are 2 points in dipole. One is two things I defined: end-on position, broad-on position. So for that, I defined the first equator, and that is basically center of dipole को fix करो. Perpendicular line passing through this point is called equator, and the line parallel to the dipole thing is called axis. ठीक है. So when we are going to calculate electric field at a point on the axis, we say we are calculating electric field on end-on position, and when we take point, any point P on this particular line, equatorial line, then we say we are calculating electric field at a broad-on position. ठीक है. So कल के क्लास में मैंने बताया था, इस पॉइंट पे अगर इलेक्ट्रिक फील्ड कैलकुलेट करना है, विच इज एट a distance d from the dipole. Let's say this distance is a, this distance is a. We have already calculated it, right? ये कैसा आया था बताओ? At point P, there will be electric field because of two charges, negative and positive. So because of negative charge, electric field will be directed in this direction. ठीक है? And value of electric field because of negative charge will be KQ by, what is this distance? This is a square plus d ka square. So this is your a square plus या लेट्स से इसको आर से इंडिकेट करते हैं, ठीक है, आर लिखना ही ज्यादा, because this is what commonly we will write. So this is this divided by square. So this is kq by a square plus r square in this direction, right? What is the electric field because of plus q charge at point P? So that is again kq by r ka r square plus a square root under iska square in this direction, right? Because this is a positive charge. Done it? Now, what will be the net electric field at point P? So that will be basically sum of these two electric fields. So net electric field आप कैसे लिखोगे? E plus Q plus E minus Q. Now let's do the addition. यहाँ अगर आप ध्यान से देखो दोनों का magnitude same है. So this is your E minus Q and this is your E plus Q. If you will break E minus Q into towards the axial and equatorial line, then what you are going to get? Let's say this angle is your theta. So if this angle is theta, there will be component of E minus Q in this direction, and that is your E minus Q cos theta. And there will be component of E minus Q in this direction, that is your E minus Q sin theta. Similarly, we are going to break E plus Q. So if you see here, if this angle is theta, this angle is also theta. And if you extend this line, this angle will also be what? Theta by vertically opposite. So E plus Q will have one component in the vertically upward direction. That is your E plus Q cos theta. And then, yes. And then in this direction, in this horizontal direction, how much? E plus Q sin theta. अगर आप ध्यान से देखो तो cos theta वाले components will get cancelled. So E net will be equal to how much? It will be equal to 2E sin theta. ठीक है, E मैंने किसको लिया है? E plus Q is equal to E minus Q is equal to E magnitude wise. ठीक है, chalo. And this direction is, I mean, this net electric field is in which direction? Is in this direction. है ना? It is in this direction. So final electric field that we are getting at this point is in this sense. That is opposite to the direction of dipole, because dipole ka direction here is in this sense, and E net at an equatorial point is opposite to the direction of dipole. What will be its value? So E net का वैल्यू कितना था? 2E sin theta. So 2 into E का वैल्यू आप क्या रखोगे? That was your KQ by R square plus A square root under इसका square into sin theta. थीटा क्या था तुम्हारा? ये एंगल थीटा था, ठीक है, and this was your R, this was your A, this was A square plus R square root under. So sin theta is how much? A by this, ठीक है, so A divided by A square plus R square का root under. Now if you are going to solve it, 2KQA divided by R square plus A square का power 3 by 2. क्योंकि here there is one power, square कर दोगे root का root हट जाएगा, so single power, and here there is half power. So half plus 1 power कितना हो जाएगा? 3 by 2. So that is why this. Now you can see here कि Q into A will be Q into 2A, K into Q into 2A. इसको ऐसे भी लिख सकते हैं, sorry, R square plus A square 3 by 2. Now tell me Q into 2A is equal to what? Dipole moment Q into 2A, that is P. So यहाँ KP divided by R square plus A square का power 3 by 2. ठीक है? If you want to write E vectorially, then you will write minus KP divided by R square plus A square 3 by 2. Done it? Because electric field ka direction is opposite to the direction of dipole at an equatorial position. This is the value of electric field. Now there is one approximation that we take. Suppose kar lo R is far greater than A. So this R is far greater than this A. Then what will be the value of net electric field? Avinash, good evening. You're coming too late. Electric field क्या होगा? K P divided by 2. Sorry, क्या था? Yes. So Okay. Just give me some time. No issue. But you should be on time. R square plus A square का power क्या लिखोगे? 3/2. This was the value, right? Now let's use the approximation. R is far far greater than A. मैं क्या करने वाली हूँ? देखो ध्यान से. देखो, these derivations are very important, not only from the point of view of your school exam, but also from the point of view of good question solving. I mean, if you're going for more good number of questions, or in, let's say, some good questions are there, so these derivation things will come into application. कहीं ना कहीं use हो जाता है, ठीक है? So here, if you take R, let's take R square as a common. So if you take R square as a common, this will become 1 plus A square by R square, and this whole का power क्या है? 3/2. Now let's write this thing. Kp, R square है and power is 3/2. So this will become R cube 1 plus A square by R square का power 3/2. Now I have told you here, we have taken assumption R is far far greater than A. Means A by R, that is 1 is far far greater than A by R. It means A by R is far far less than 1. ठीक है? And here we are doing A square by R square. So this term, term in the denominator is very, very small, very, very small, almost near to 0. So what we will do is Kp by R cube 1 plus 0 का power 3/2. इसको almost 0 मान रहे हैं, ठीक है? So this will become Kp by R cube. Done है? So if you say कि this R is far far greater than A, then at this point electric field will be Kp by R cube in this direction. ठीक है? Anyone having any doubt so far? किसी को डाउट है? Anyone? नहीं? चलो ठीक है. Now we will calculate electric field at an axial point. Let's calculate electric field at point P. Let's say this distance of point P from the center of dipole is small r. So electric field at point P because of charge plus q will be how much? It will be kq divided by this distance. Plus q से p का इतना distance है, and this distance will be equal to how much? This is your A, and this whole is R. So this will be how much? R minus A. So KQ by R minus A ka square. And what will be the direction of electric field at point P because of plus Q? From plus Q charge, electric field will come out. So at P, electric field because of plus Q will be in this direction. Okay? Now let's calculate electric field at that point because of negative charge. So first, let us calculate the magnitude. How much it will be? So this whole is R, this is R, and this is A. So total distance is R plus A. Now you will write KQ by R plus A का whole square. ठीक है? Done it? Now what will be the direction? So if you talk about direction, then because of negative charge, at negative charge electric field will end. So if you will extend this line, electric field will go like this. Okay? Because it has to end at minus q. So electric field because of minus q charge at this point P will be directed in this sense. Okay? Both are oppositely directed. So electric field because of plus q is in this direction, because of minus q is in this direction. And clearly you can see this denominator is smaller, this is greater. So if denominator is smaller, value will be larger. So E plus Q is greater than E minus Q. And so net electric field हम क्या लिखने वाले हैं? E plus Q minus E to the power E minus Q. ठीक है? So net electric field plus Q से minus Q को कर रहे हैं. Done it? And so net electric field will be in this direction. That is the direction of dipole. है ना? Minus Q से plus Q की direction में ही dipole का direction होगा. So this is the direction of dipole, and also net electric field is in this direction. So basically net electric field at axial point will be in the direction of dipole. चलो अब values को हम लिख डालते हैं. So E plus Q KQ by R minus A का whole square minus KQ by R plus A का whole square. Solve it. If you will solve it, what you are going to get? So KQ को common ले लो. 1 by R minus A का whole square minus 1 by R plus A का whole square. So if you are going to do this, KQ, R square plus A square plus 2AR minus of this thing, that is R square plus A square plus, sorry, minus, because this is R minus A का square minus 2AR. ठीक है? And this divided by R minus A का square or R plus A का square. So if you solve it, what will happen? This will get cancelled with this. This will get cancelled with this. This minus minus will become plus. So this is 4AR into KQ divided by, this is R minus A, R plus A. So this is R square minus A square का power how much? का square. ठीक है, मैंने कैसे लिखा? मैंने ये फॉर्मूला यूज किया सिंपल सा, A प्लस बी और A माइनस बी क्या होता है? A स्क्वायर माइनस बी स्क्वायर होता है, एंड इस पूरे का स्क्वायर है यहाँ पे, सो इसलिए मैंने इसका क्या कर दिया? स्क्वायर कर दिया. ठीक है, सो 4AR इंटू KQ. अब इसको चलो इलेक्ट्रिक फील्ड वैल्यू को लिखो, K इंटू Q इंटू 2A इंटू 2, है ना? 4A को हम क्या लिख सकते हैं? 2A इंटू 2 डिवाइडेड बाई R स्क्वायर माइनस A स्क्वायर का पावर का स्क्वायर. ठीक है, Q into 2A can be written as P. So this is 2KP by R square minus A square का power का square. And if you talk about electric field direction wise, if you write it as a vector, then electric field is in the direction of dipole. So E and P are parallel here. Done it? This is the magnitude we are getting. If we do again the same assumption, let's say R is far greater than A, then 2KP by क्या आया है? R square minus A square का power 2. So if you go on to write it, 2KP, R square को common ले लो. If you will take it, R square common होगा तो यहाँ R4 हो जाएगा. We have missed on certain thing, I guess. यहाँ पे 4AR भी था, यहाँ पे we have left R. R को हमने लीव कर दिया. देखो यहाँ R था ना, so this R we didn't write here, so I have written here now. ठीक है, so 2KPR R4 1 minus how much you are going to write? A square by R square का power का square. ठीक है, clear है? चलो, now if R is far greater than A, then this term will become almost equal to 0, and you will get here 2KPR by how much? R4, and 1 R will get cancelled, so you will get 2KP by RQ. ठीक है, so electric field vectorially you will write like this at an axial point. ठीक है, what is the summary? Summary is that if you have to calculate electric field at an equatorial point, it is opposite to the direction of dipole and its value is Kp by Rq if R is far greater than A, and at an sorry, this is at an equatorial point. At an axial point, electric field is equal to 2Kp, that is double of that at equatorial, by Rq if R is far greater than A. And direction wise you can see, at axial point it is in the direction of dipole, at an equatorial point it is opposite to the direction of dipole. किसी को डाउट है यहाँ तक तो बताओ. I will wait for 1 minute. ठीक है, let me know if you have a doubt. No one? No doubt? Kiran, this formula I should revise or derivation you are talking about? Okay, I will take you through the slide again. ठीक है, तो देखो मैंने पहले क्या किया, इक्वेटोरियल पॉइंट के लिए जैसे तुम्हारे पास क्या था? ये रहा तुम्हारा डाइपोल। डाइपोल ऐसा दिखता है, एक है तुम्हारा माइनस क्यू चार्ज, यहाँ है प्लस क्यू चार्ज। एट एन इक्वेटोरियल पॉइंट यू आर कैलकुलेटिंग इलेक्ट्रिक फील्ड, सो मैंने ये किया। बिकॉज ऑफ नेगेटिव चार्ज इलेक्ट्रिक फील्ड विल बी डायरेक्टेड टुवर्ड्स नेगेटिव चार्ज, so electric field at point P because of negative charge will be directed in this sense, and because of positive charge it will be outward, so at P it will be in this sense. Then what I did is I calculated magnitude. So magnitude of electric field because of plus q minus q will be same because they are symmetrically placed. This distance is r square plus a square. This distance is also r square plus a square. Magnitude of positive and negative charge is same. So E minus Q or plus Q ka magnitude is same. Direction are different. So we need to add them vectorially. Before adding, I have broken it into components. So यहाँ पे अगर आप ध्यान से देखो तो इस केस में दो इलेक्ट्रिक फील्ड्स जो दिख रहे हैं उसको कैसे कैसे ब्रेक कर सकते हो. सी हियर, दिस इज वन ई, even let's say this will have a component in this direction. I call this angle as a theta. So this will be even sine theta because this is making 90 minus theta angle with this. So even sine theta, and along this it will be even cos theta. And because of plus q, let's say electric field is E2, it will have one component in this direction, E2 cos theta. And here it will be, sorry, not in this direction it is. Again in this direction, E2 will have a component, E2 sine theta. So basically, E net will be because of horizontal component of both E plus Q and minus Q getting added, that is 2E sine theta. After that, what I did is I have broken E into its value, that is KQ by R square plus A square. And then I put in the value of sine theta, which is A divided by, I mean इस triangle की अगर आप बात करो इस triangle में, तो sin theta कितना है तुम्हारा? Sin theta is A by root under A square by R square. So मैंने ये put किया. After that I have just done mathematics. So uh, if you will do the mathematics, you will get electric field minus Kp. Why minus? Because electric field direction is opposite to the direction of dipole. It is this thing. After that, what I did is for r far greater than a, I have taken here r square common. I took. Again, mathematics, r cube will be remaining. If r is far greater than a, then a square by r square is almost 0. So this is kp by r cube 1 plus 0. So kp by r cube. Okay. Similarly, I did for axial point. Again, I calculated electric field at P because of plus Q and minus Q. So because of plus Q, electric field will be in this direction. Because of minus Q, it will be in this direction, oppositely directed. Plus Q value is greater than minus Q value. So I subtracted minus Q wala value from plus Q. And hence direction of net electric field will be in the direction of electric field because of plus Q, because that is greater. So electric field is in this direction. That is in the direction of dipole. If you will again do the mathematics, you will get here these values. Okay? And if you again approximate R is far greater than A, you will get this. That is in the direction of dipole. Okay? Thank you. Thank you. Chalo. Now electric field due to dipole we have calculated at 2 points. One is axial. ठीक है? अगर आप इस point पे देखो तो ये वाले point क्या थे? This point was your axial point. And what is this point? This is an equatorial point. ठीक है? चलो. So इन दोनों पॉइंट्स पे तो हमने इलेक्ट्रिक फील्ड निकाल लिया. बट व्हाट इफ वी आर गिवन और वी आर आस्क्ड टू कैलकुलेट इलेक्ट्रिक फील्ड एट एनी रैंडम पॉइंट. लेट्स से एट पॉइंट P we have to calculate electric field. So we know two formulas. One for the axial point. Axial point पे कितना होगा? 2 kp by r cube in the direction of dipole. What will be electric field at equatorial point? Equatorial point पे क्या होगा बताओ? That will be your kp by minus kp by r cube. So we know two formulas only. What if we have to calculate electric field at any other point? Then there is a logic we can follow. यहाँ पे देखो, this is the dipole, minus q plus q, ठीक है? So एक काम करना, इस dipole को पहले लिख लो. So this dipole is like this. This is the dipole, ठीक है? And we have to calculate electric field at point P, which is making an angle how much? Theta with the dipole, right? So now you do one thing, break this dipole into two components, one along the line joining P and another perpendicular to line joining P. तो P का दो कंपोनेंट कैसे दिखेगा देखो, ये हो गया तुम्हारा P cos theta and another one perpendicular to that line, that is your P sin theta. So अब हम क्वेश्चन को कैसे देखेंगे, वी विल लुक एट इट लाइक वी हैव टू डाइपोल, वन इज P cos थीटा एंड अनदर इज योर P sin थीटा, ठीक है, एंड वी हैव जस्ट गिव मी ओके, जस्ट गिव मी सम टाइम. Okay, chalo, let's get started now. So now we have two components of P. One is your P cos theta, another is P sin theta. So now look at this question in a different way. और वो different way क्या होगा? Now we will call it. We have two dipoles. One is in this direction P cos theta, and another is in this direction P sin theta. And we have to calculate electric field at this point P. So if you look here carefully, this point P is axial point for the dipole P cos theta. Don't you agree? Batao. This point P is what? Axial point for the dipole P cos theta. What do you say? Yes. Because P cos theta is directed in this sense, in this line, and also P is lying on this line. So for P cos theta, point P is what? It is, yes, Lakshmi, thank you. So this point P is an axial point for P cos theta. And for P sin theta, if you look at P sin theta carefully, so P sin theta ka line ye hai, axis ye hai, and P point is here. So this line is basically equatorial line for P sin theta. डन है. सो P sin थीटा के लिए ये इक्वेटर हुआ और P cos थीटा के लिए ये एक्सिस हुआ. डन है. नाउ वी कैन इजीली कैलकुलेट इट. हाउ? जैसे देखो, अब मैं एक काम करती हूँ, ऐसा था हमारा डाइपोल, लेट्स से दिस वाज आवर डाइपोल, ठीक है, यहाँ माइनस क्यू चार्ज था एंड हियर देयर वाज अ प्लस क्यू चार्ज एंड देन देयर वाज अ पॉइंट P हियर. सो this is your P cos theta wala line. So because of P cos theta, what is the electric field at point P? So because of P cos theta, electric field will be, this is the axial point for P cos theta, right? So formula will be 2 kp cos theta divided by RQ. And what will be the direction of electric field because of P cos theta at point P? It will be in the direction of dipole. So it will be in this direction. Let's say this is E1. Okay, so this is E1. Now what about P sin theta? So P sin theta ke liye, this point is an axial, equatorial point, because this is P sin theta, right? So this is an equatorial point and it is at a distance of what? R. So the formula will be, because of what? Electric field because of P sin theta will be 2 kp sin theta, sorry, not 2 kp. इक्वेटोरियल पॉइंट पे फॉर्मूला क्या होता है? kp by r cube. So here k, p का वैल्यू क्या है? P sin theta by r cube. And what will be the direction? So direction will be opposite to the direction of dipole. Dipole का direction P sin theta का इधर है. So at this point electric field E2 will be in this direction. Now net electric field, how you will calculate? You will simply do E1 square plus E2 square. Is it clear, everyone? If yes, let me know. और कोई डाउट है तो you can tell me. Yes. माइनस, यस माइनस लिया ना मैंने, डायरेक्शन में दिखा दिया ना माइनस को, ऑपोजिट दिखाया ना. तो माइनस इज बेसिकली दैट indicates direction. Done it. So direction already I have drawn. I have simply written the magnitude. So magnitude will be this. That is why no negative sign I have given. समझ रहे हो? जैसे at an equatorial point, electric field is opposite to the direction of dipole, and that is why while writing the formula we give negative sign. But here direction I have already indicated by arrows. Simply I have written the magnitude. So no negative sign. ठीक है? चलो. Thank you. रेजोल्यूशन ऑफ पी नहीं समझ में आया तुम्हें, ठीक है. जैसे देखो यहाँ पे एक काम करो, तुम लोग वेक्टर सही से फॉलो नहीं किए हो. मैं इसलिए बोल रही थी बार बार, प्लीज 11th क्लास पे थोड़ा फोकस कर लो प्लीज. वेक्टर को हम रिजॉल्व कैसे करते हैं? लेट्स से दिस इज अ वेक्टर, दिस इज अ वेक्टर पी, लेट्स से, एंड वी हैव टू रिजॉल्व इट इन टू डायरेक्शंस. या फिर एक काम करो, मैं तुम्हें और भी डिफरेंट वे में समझाती हूँ. Let's say this is coordinate axis and then we have a force F and this angle is theta. What is the component of this force F along x-axis? That is F cos theta. How we resolve vector? For resolution, we see what angle it is making with certain direction. Suppose we have to resolve F along x direction. So we will see what angle it is making with the x direction. It is making theta angle. So component of F along x-axis will be F cos theta. And along this direction, if you have to check, then what is this angle? 90 minus theta. So what will be the component of F along y-axis? F cos 90 minus theta. And F cos 90 minus theta kya hota hai? Sin theta. And that is why F sin theta. Here there is a dipole in this direction. Done. This is a dipole in this direction. So this dipole is making an angle theta with this direction. So here component will be P cos theta. And if you take this direction, one more perpendicular direction, then with this direction, it is making an angle 90 minus theta. So component will be P cos 90 minus theta. That is P sin theta. ठीक है? इसलिए मैंने यहाँ पे two components लिए थे. Wherever I have taken it, I mean, yes, here. Yes, in this case itself. ठीक है? Thank you. चलो चलो आगे बढ़ते हैं. नाउ लेट्स कैलकुलेट द पोटेंशियल. सो पोटेंशियल निकालना इज मोर इजी, क्योंकि इसका डायरेक्शन नहीं होता है ना. अगर डायरेक्शन नहीं है तो वेक्टोरियली नहीं है, स्केलरली ऐड करना है. सो इट्स वेरी इजी. एट पॉइंट पी व्हाट विल बी द पोटेंशियल बिकॉज ऑफ नेगेटिव चार्ज? सो पोटेंशियल बिकॉज ऑफ नेगेटिव, सॉरी नॉट इलेक्ट्रिक फील्ड, what will be potential because of negative charge? Kq minus kq, because potential because of negative charge is negative. And this distance is how much? R square plus A square. So this is R square plus A square. What will be potential because of plus Q charge at this point? So we will check this distance. Again, this is R square plus A square. So V plus Q will be KQ by R square plus A square root under. ठीक है? What is total potential? बताओ कितना दिख रहा है? दोनों को प्लस करोगे टोटल पोटेंशियल के लिए, दोनों पोटेंशियल को ऐड कर दो. इफ यू आर एडिंग दिस टू पोटेंशियल, व्हाट यू आर गोइंग टू गेट? टेल मी. यस, क्या होगा पोटेंशियल का टोटल वैल्यू ऐड करने के बाद व्हाट यू आर गोइंग टू गेट? Add these two potentials, you will be getting something. What is that you're getting? Yes, Ranju, very good. Thank you. Others, please. You people are not following the lecture, most of you, I feel. Add करो यार, add करके देखो क्या आ रहा है. This is minus of kq by this, and this is plus of kq by this. Both are same in magnitude with opposite sign. One is negative, another is positive. So 0. It is same like you are adding -2 with +2. So you will get 0, right? Yes, Kiran, Lakshmi. It will be 0, right? So 0 hai. Yes, 0. So now calculate potential at an axial point. Let's say at point P, we are going to write potential because of plus Q charge. So potential because of plus Q charge at point P will be how much? Distance from here to here is given as what? R. And this distance is A. So what will be this distance? R minus A. So potential will be equal to KQ by R minus A. And what will be because of negative charge? So from negative charge, it is at a distance what? At what distance? This is R and this is A. So this whole is R plus A. So minus KQ by R plus A. Total potential will be what? V plus Q plus V minus Q. Add these two. KQ by R minus A plus KQ by R plus A. It's not 0, right? So let's solve it. KQ R plus A plus R minus A divided by R square minus A square. So if you solve it, this is A will get cancelled. है ना? So what value we are going to get? KQ R by R square minus A square. ठीक है? Again we can take approximation and we can check. जैसे हमारा आंसर कितना आया इतना. And if we do here one thing, that is R is far greater than A, then what will be the thing? कैसे लिखोगे इसको बताओ? Then you will write KP by R square को common ले लो. 1 minus A square by R square. Again A square by R square will become 0 almost. So this will become KP by R square. So potential at an axial point is equal to what? KP by R square. And what is potential at an equatorial point? Any equatorial point, that is 0. ठीक है? One more noticeable thing here is electric field जो भी तुमने निकाला था, देख लो यहाँ पे, whatever we have calculated, electric field is directly proportional to R का cube. ठीक है? And what about the potential? If you look at potential, that is directly proportional to R का square. दिख रहा है? Potential is directly proportional to R का square. Sorry, 1 by R का square. मैंने opposite लिखा क्या इधर? Directly नहीं, yes, directly proportional to 1 by R cube, and potential is directly proportional to 1 by R का square. So these are the things. Done it? Now we will also calculate potential at any random point P. Okay? This is also a derivation that requires your mathematics. So what we will do, let's say this again the same dipole we are taking, minus Q plus Q separated by distance 2a. This is theta. And at P we are going to calculate the potential. Please just stay everyone with patience. So P point ka distance minus Q say, let's say this is R2, and with plus Q, let's say this is R1. Done it? Since this is not an equatorial point, we cannot calculate it by Pythagoras theorem. R2 को हम नहीं निकाल सकते Pythagoras theorem से. Done it? But what other geometry thing we can do? सबसे पहले तो total potential at P will be because of potential of plus Q charge plus potential of minus Q charge. So potential of plus Q charge देखो कितना होगा? That will be KQ by R1. And what will be potential because of negative charge? This will be equal to minus KQ by R2. Done है? R1 R2 we don't know it. ये हमें पता नहीं है. ये हमें R1 R2 को निकालना है in terms of theta and A. That we will do. ठीक है? So this is this. Now is the task to calculate what is R1 and what is R2. So for this we will apply one geometry. और वो geometry ये है कि let's say this is a triangle. Let's say this is a triangle. ठीक है? Let's say this is your side A1, this is A2 and this is A3. Let's say this angle is theta and this angle is alpha and this angle is beta. Now A1 square को आप क्या लिख सकते हो? A1 square can be written as, ठीक है, A1 square can be written as A2 square plus A3 square minus 2A1 A3 cos of which angle? This angle. यानी कि A1 से जो ऑपोजिट वाला एंगल है, ये वाला है A1, ठीक है. What is the angle opposite to it? This is alpha, ठीक है. So A1 square can be written as A2 square plus A3 square minus 2A2 A3 cos alpha. This is the formula, ठीक है. ये तुम्हारा ट्रिग्नोमेट्री में पढ़ना है. So मैथ्स के स्टूडेंट को पता होना चाहिए. जिनको नहीं पता है उनके लिए मैं बता दूं, इस तरह का ये फॉर्मूला होता है. सिमिलरली अगर आपको लिखना है A2 का स्क्वायर, तो A2 के स्क्वायर को आप क्या लिखोगे? बाकी दोनों साइड कौन बच गया? A1 and A3 are left. So here you will write A1 का स्क्वायर प्लस A3 का स्क्वायर एंड A2 से ऑपोजिट कौन सा एंगल है? देखो बीटा. So here you will write minus 2A1 A3 cos beta. Similarly, if you have to write A3 का square, so A3 का square will be A1 square plus A2 square plus minus 2A1 A2 and what is the angle? Cos theta. So this is how we write it. Done है? अब देखो अगर मुझे R2 का स्क्वायर लिखना है या R1 का स्क्वायर लिखना है. R2 का स्क्वायर लिखना होगा, I will utilize this triangle, ठीक है. And this angle is how much? 180 minus theta. So R2 का square, can't you see? We can write it like R square plus A square minus 2AR cos 180 minus theta. ठीक है. Similarly R1 का square we can write. So R1 का square क्या लिख सकते हैं? R square plus A का square minus 2AR cos theta. This one. R2 का square, R square plus A square minus 2AR cos 180 minus theta. And cos 180 minus theta is what? Cos 180 minus theta is in second quadrant and that is why it is equal to minus cos theta. So इसलिए ये minus minus plus हो गया. So this is this. ठीक है. अब चलो suppose कर लो R is far greater than A. Again we are going with the assumption. तो R1 स्क्वायर को हमने क्या लिखा है? ऐसा लिखा था, ठीक है. अब इसको मैं सॉल्व करती जाऊंगी. R स्क्वायर को कॉमन ले लो, ठीक है. यहां से क्या करो? R स्क्वायर को कॉमन ले लो. सो यहाँ 1 बचेगा. दिस इज A स्क्वायर बाय R स्क्वायर. दिस इज माइनस 2A बाय R cos थीटा. अब देखो R is far greater than A. It means what? A is far greater than R. A by R will be far less than 1. लेकिन अगर आपने स्क्वायर कर दिया तो ये और भी छोटा हो जाएगा, बहुत छोटा हो जाएगा, such that we can neglect this term. ठीक है. A by R is larger in comparison to A square by R square. So let's cancel here A square by R square. So R square 1 minus 2A by R cos theta. We will be writing R1 square like this if R is far greater than A. So same thing I have done here. I took the common. Then I neglected this term, right? And this thing you got. So R1 square is equal to this much. Okay. And what will be the value of R1 then? R1 square is how much? R1 square is this. अगर R1 निकालना है, ये root इधर जाएगा. So this is R square 1 minus 2A by R cos theta का root. Root means power is half. So R square का R हो जाएगा. And 1 minus 2A by R cos theta half. ठीक है. अब देखो यहाँ पे एक और कॉन्सेप्ट है मैथ्स का, और ये सारी चीजें तुम लोग नोट करके रखना, नीट वाले स्टूडेंट खास करके, बिकॉज this thing you won't be getting anywhere because you are not following mathematics, right? So there is a thing, if you encounter equation like 1 plus x to the power n, where x is far, far less than 1, then this can be written as 1 plus nx. Why it is important here? क्योंकि यहाँ पे देखो हमारा जो ये इक्वेशन है ना, या फिर यहाँ पे 1 प्लस हो या फिर 1 माइनस एक्स हो, जो भी हो, यू कैन, आई मीन, लेट मी डू इट मोर क्लियरली. 1 प्लस एक्स है तो 1 प्लस एन एक्स हमने लिखा. If there is 1 minus x का power n such that x is far far less than 1, then you can write 1 minus nx. ठीक है? तो this equation is in form of 1 minus x, where 1 is 1, x value कितना है? 2a by r cos theta. And this 2a by r cos theta is far far less than 1 because a by r is far far less than 1, right? A by r is what? Far, far less than 1. So 2a r cos theta is also far, far less than 1. So here we can apply this formula. 1 minus x to the power n को क्या लिख सकते हैं? 1 minus nx. ठीक है? So if we apply this formula, this will become how much? R. Half will come here. ठीक है? And then you will be writing what? This will become R. यहाँ पे लिख डालती हूँ, मैंने लिखा नहीं है. R 1 minus 2a by r into half, power अंदर आएगा, into cos theta. So 2 will get cancelled. This is r basically. So this will become 1 minus a by r cos theta. ठीक है? Am I clear? Everybody getting it? Yes. मैथ समझ में आया तुम लोगों को? ओके, अविनाश. Others please. चलो तुम लोग थोड़ा टाइम लो चीजों को समझने के लिए. ठीक है, मैं एक बार स्लाइड को थोड़ा स्लो रखती हूँ so that you can understand. ये सारे स्टेप्स तुम देखो थोड़ी देर के लिए. ठीक है, check it. I will keep on letting it go forward. ठीक है, सो अगर आप कॉमन लेते हो तो क्या बचेगा? यहाँ पे ये वाला टर्म बचेगा, r इंटू 1 माइनस ए बाई आर कॉस थीटा. ठीक है, एंड सिमिलरली R2 के लिए जब आप करोगे तो ये 2 नहीं होगा, 2 मैंने एक्स्ट्रा में लिख दिया है. 1 प्लस ए बाई आर कॉस थीटा, जैसे यहाँ आया 1 माइनस ए बाई आर कॉस थीटा, हियर यू विल बी गेटिंग 1 प्लस ए बाई आर कॉस थीटा. क्यों? क्योंकि देखो इनिशियल में अगर आप जाओ तो R2 square is what? R square plus A square plus 2AR cos theta. R1 square is minus 2AR cos theta. So there will be difference showing up here also. ठीक है, अब देखो R1 का वैल्यू क्या आया, इसको कैंसिल करो. 1 R इंटू 1 माइनस ए बाई आर कॉस थीटा. ओके, अभी तक मैंने कॉमन लिया नहीं यहाँ पे, तो यहाँ 2 होगा. R2 का वैल्यू ये सेम आएगा. इफ यू विल अप्लाई what 1 minus x to the power n का फॉर्मूला, you will be getting what? You will be getting, I mean, देखो एक काम करो, पहले हमें पोटेंशियल निकालने के लिए क्या चाहिए? R1 चाहिए, 1 by R1 चाहिए. देखो हमें पोटेंशियल निकालना है ना, दिस इज KQ by R1. So basically this is KQ into 1 by R1, right? Similarly this is what? Minus KQ into 1 by R2. So we need 1 by R1 and 1 by R2. डन है? चलो यहाँ तक तो तुम लोग समझ गए थे. मैंने यहाँ पे कैसे निकाला, R1 कैसे निकाला है ना? R1 is this. Let's not do the extra thing. तुम्हारा R1 का वैल्यू कितना आया? इतना. Let's for now not apply 1 minus x to the power n or 1 plus x to the power n का formula. अभी मैं apply नहीं कर रही. So R1 value is this, R2 value is this. ठीक है. So again, whatever I have written is correct. R1 is this, R2 is this. What will be 1 by R1? So if you will do 1 by R1, you will simply do 1 by this. So that will become 1 by R. और 1 minus 2a by r cos theta का पावर क्या हो जाएगा? माइनस हाफ. नाउ यू अप्लाई द फॉर्मूला जो मैंने बताया था, 1 प्लस एक्स टू द पावर n या फिर 1 माइनस एक्स टू द पावर n. ये किसके बराबर होगा? 1 प्लस एन एक्स. ये किसके बराबर होगा? 1 माइनस एन एक्स. When you will apply this formula if x is far less than 1. Here 2a by r is 2a by r cos theta is far less than 1. So 1 by r1 will be equal to 1 by r minus half power n को अंदर लाओगे. So plus हो जाएगा. What it will become? 1 by r. चलो मैं इसको इंडिकेट करके लिखती हूँ. 1 माइनस ऑफ 1 by 2 इंटू 2a by r cos theta. ऐसे ही लिखोगे ना. माइनस माइनस क्या हो जाएगा? प्लस. सो 2 कैंसिल होगा. 1 प्लस a by r cos theta. सिमिलरली r2 आप निकालोगे. सो 1 by r2 is this. When you will take nx n अंदर, you will get 1 by r 1 minus a by r cos theta. So 1 by r1 we got here, 1 by r2 we got here. What will be the value of Vp now? Kq 1 by r1 minus 1 by r2. Put in the values. 1 by r1 is this, 1 by r2 is this. Now you need to solve it. So आप अब इसको solve कर दो. 1 by r plus a by r square cos theta minus 1 by r plus a by r square cos theta. If you see here, this will not get cancelled. This will get cancelled, and this will become kq into 2a by r square cos theta, and q into 2a will be equal to p. ठीक है. So यहाँ से this thing we are getting, and this will become equal to p. So this one you can write as kp cos theta by r square. ठीक है. This also can be written in a vector term. लाइक डॉट प्रोडक्ट. जैसे देखो ये है P का डायरेक्शन, यही है ना P का डायरेक्शन, एंड दिस इज योर R वेक्टर. एंगल बिटवीन R वेक्टर एंड P वेक्टर इज व्हाट? थीटा. सो हियर आई एम राइटिंग इट लाइक P डॉट R, K P डॉट R by R cube. Will this be same as KP cos theta by R square? Yes, क्योंकि इसको अब आप ब्रेक करो. This will become K P dot R क्या होगा? PR cos theta by R cube. So this is equal to Kp cos theta by r square. So what is the value of electric potential at any position vector P, or at any point P, is what? Kp cos theta by r square, and that is equal to how much? Kp dot r by r cube. ठीक है. यहाँ से you can calculate for axial point and equatorial point also directly from the formula. जैसे for axial point, angle between P and R is what? Theta. Theta is what? 0 degree. Because here R vector is in this direction. Dipole ka direction is also in this direction. So angle is 0 degree. If you will put here theta 0, cos 0 is 1. So answer will be Kp by R square. And that is what we got for axial point. For equatorial point, we have got 0 as the answer. So for equatorial point, angle between R vector and dipole moment is 90 degree, cos 90 is 0. So potential at equatorial point will be always 0. So here we covered up to dipole. I mean, we covered what will be electric field because of dipole. We covered what will be potential because of dipole. कल के क्लास में we will read a bit more what happens when we place dipole in external electric field, and after that we will start with again small portion is just left, electrostatics of potential of conductors and all we will read. But first we will focus on this, and in 2 classes electrostat will get finished. ठीक है. After that in 1 class we will be doing questions. Done. Anyone having any doubt, then let me know. किसी को कोई डाउट है तो बता दो. Anybody? Lakshmi, Avinash, Kiran. थैंक यू, थैंक यू, थैंक यू। रंजू, कोई डाउट है? जिनबी हैदराबाद, कार्तिक, पांडु, नोबडी? चलो ठीक है, ठीक है एवरीवन, देन टेक केयर ऑफ योरसेल्फ, वी विल बी मीटिंग टुमारो विथ अनदर पर्सन। ठीक है, बाय एवरीवन, टेक केयर।